So hi everyone, my name is Abhinav and in this video I shall be talking about one of the most important concept in deep learning, which is GANs, Generative Adversarial Networks. So at the end of this video you shall get a clear idea about it. So let's get started. So let's begin. Why this topic is important. So in deep learning most models are great at recognition or classification things. For example, a neural network can tell whether an image contains a cat or dog. So, but what if we want our model to create a new cat or dog that does not even exist? So this is where the our topic comes, which is generative adversarial networks came into the picture. They allow machines to generate new realistic data like image, audio, or even videos that looks like real one. So a simple way to understand is think it like there are two opponents, which is the generator and the discriminator. So what the generator does is it creates the fake currency that looks real. So while the other one, the detective or the discriminator, tries to identify whether it's genuine or fake. So over the time, both get smarter, and eventually the generator becomes so good that the detective can't even classify whether the image is or the data given is real or not. So that's exactly what happens in here. So let's go to the next. So what are the generative adversarial networks? So they are introduced by the IAN Goodfellow in 2014. So they consist of two deep learning models, the generator and the discriminator, which are trained together in a competitive setups. So the generator takes random noises as input and produces a synthetic data like fake images, and the discriminator on the other hand looks at both real data and the generative data and decides which one is real. So this process continues in a loop, and the generator tries to fool the discriminator continuously, and at the same time the discriminator also tries to be not to be fooled. So both networks keep improving until the generated data looks like exactly real and such that we can't make a difference from both. So in short, the GANs learns to capture the underlying distribution of real data and the generative new samples from it. So example, uh, so the generator creates a photorealistic human faces, landscapes or even artworks that are completely synthetics but look real like a human eye. So let's see the working mechanism. How does it works? So this is the most important step. So let's understand how it actually works internally. So as I said, there are two components, which are the generator and the discriminator. So the generator starts with a random noise vector, usually denoted as Z, and it passes it through a neural network to produce a fake data like an image. So here the discriminator takes this fake data along with the real data from the dataset and outputs a probability whether the input is real or fake. So both networks train simultaneously. So the generator goal is to generate data that discriminator will classify as real. Also, the discriminator goal is to correctly identify which samples are real and which are the generated one. So during training, the backpropagation is used, which update both parameters model. So eventually, the generator improves so much that the discriminator can no longer tell whether the image is fake or real. That's when we say the GAN has converged. So if we look practical examples of it, so it can turn sketches into realistic photos, enhance low resolution images, or even generate entirely new artwork and designs. So next is the challenges and limitations. What are the drawbacks or limitations of it? So the first is training instability. So this is one of the important point to get noted. So training instability is that both networks must improve together, and if one gets too much strong, the model fails to converge. The next one is the model mode collapse, which is sometimes the generator keeps producing very similar outputs and at the same time the discriminator loses diversity. Third one is high computation cost though, so it needs a powerful GPU and lot of data to get trained from it. Also, the last one is the most common, which is ethical misuse. One of the biggest concern is about the creation of deepfake, which can spread the misinformation of fake identities. So, while GANs are amazing in creativity, they can must be used responsibly. So, let's summarize what we have learned. So, the key takeaways from the generative adversarial networks are, so basically, as I said, there are two components. So, generative adversarial networks are the breakthrough in the deep learning that allows a machine to create new, realistic data rather than just it analyze it. So, we have transformed fields like art, healthcare, entertainment, and data augmentations. Although challenges like stability and ethical use remain, the future GANs looks incredible promising, especially in creative and AI jobs. So that's it for this video, and I hope you have got the point about what actually happens with the GANs. And thank you.